In 2022, Stefan Li and Fortier envisioned a document editor with language model features built in. They founded Type.ai, received backing from Y Combinator, and have since been at the frontier of building a next-generation document editor. However, to ensure a robust and performant front end, Type.ai needed to take advantage of many modern browser features. Stefan Li is the CTO of Type.ai, and he joins the show to talk about the state of front-end dev, the ServiceWorker API, IndexedDB, the SharedWorker interface, weblocks, and more. Gregor Vand is a security-focused technologist and is the founder and CTO of MailPass. Previously, Gregor was a CTO across cybersecurity, cyber insurance, and general software engineering companies. He has been based in Asia Pacific for almost a decade and can be found via his profile at vand.hk.
Hi, Stefan. Welcome to Software Engineering Daily.
Thanks for having me.
Yeah, so Stefan, really great to have you on the podcast today. And just a quick fun fact, it was you who, in fact, even introduced me to SE Daily many moons ago. So this is kind of fun that we're recording this episode today. Yeah. So you are one of the co-founders and you're the CTO of Type.ai. And we're going to hear all about the platform, and we're definitely going to be diving into a lot of the technical parts today. But I think just before we dive into Type.ai, I certainly know you've had a pretty successful career before all this in different roles in software engineering. Yeah, could you maybe just give us a bit of a whirlwind tour of Stefan's life before Type.ai?
Yeah, whenever someone asks this, I'm forced to recognize the fact that I've been a software engineer for like 15 years now, which is kind of shocking whenever I think about it. But yeah, so right after uni, I started in actual mobile development. And this was kind of just a couple of years before smartphones, started coming out. So it was mostly C and Java. And then when smartphones came out, I started doing some iPhone stuff and then kind of transitioned into Android. And I spent a couple of years at Sony Ericsson, then a couple of years at Walmart, helping them build their first mobile apps on Android. And then after that, I did a few failed startups, then spent some time at Meta, again, doing Android stuff. And then after that, I decided I was going to try my own thing again. And I started a solo project, which was like a flashcard-based application. And I did that for a couple of years, and that was mostly web-based. So I kind of transitioned into web development at that point. And the reason being that it was a desktop-first application, basically. So it made sense to transition to web. And so I did that for a while. And it was kind of tough just being a solo developer. And I hit like a point where I was like, I still had some energy left, but I was like close to kind of giving up. And at that stage, I met my current co-founder, Stu, in New York at a co-working space, actually. And this was end of 2022. And so, yeah, Stu, he actually sat next to me at our co-working space, and we kind of became friends. And he one day just pitched me this idea of like, hey, what do you think of an AI-powered document editor? And at the time, it felt like a very novel idea. This was before ChatGPT was out by a few months, basically. And so language models, they were a thing, but they were nowhere sort of like regular people just didn't know what it was, right? And so on. So yeah, it seemed like a really novel idea. I was like, yeah, this sounds good. And I had some experience working on editors from the flashcard application, rich text editors. So yeah, we decided, let's do this. And we applied to YC, and then, yeah, the rest is history.
Yeah, and you got into YC, and yeah,
right.
Got some follow-on funding from there. Yeah, I think I remember you mentioning when you kicked this off, and I think you said to me, have you heard of the OpenAI APIs? And I was like, no, I haven't. It's very funny to think back. There was a time when a developer wouldn't even be aware of them. And it was not that long ago in relative terms. So it's kind of fun.
Things went crazy very fast. I mean, it was like a matter of months. And we went from thinking we were a novel idea to having like maybe 20 sort of competitive products, which was like pretty gnarly, but in some ways also forces you to, have conviction in your idea and continue forward. So, yeah.
Yeah, completely. before we dive into sort of more of the weeds a bit on the pure technical, could you just give a kind of, I mean, you've sort of done it already, but like a high level of Type.ai? And I guess you've already kind of touched on it. It is, very much powered by LLMs, and I'm aware it's OpenAI is one of them that you like. GPT is one that you use, and Claude from Anthropic is, I believe, one of the other main that you use. Could you just speak a bit to kind of the choices there as well? That'd be kind of interesting to hear.
Yeah. So the sort of 2-sentence version is like we're building a document editor with AI tools on top that helps the user write in different ways, right? So by document editor, we mean something akin to Google Docs, and then AI tools that can help you sort of generate ideas, that can assist you with kind of iterating on your text, generate content. And really the goal is kind of just to accelerate the writer's journey, right? Going from inception to the finished stage. We just want to help speed that up in any way we can while retaining or maybe even improving quality. And so there's really 2 main pillars here. One is like creating what we feel like is a really good editing experience, even if you take the AI stuff aside. And then there's like the AI component, which obviously is very important, but we kind of want both to be able to stand alone in some ways. And so the AI component is, how do we best provide the UX interaction sort of between an editing environment and an LLM? And so in terms of the models, we try to build it with the thinking that these models will always improve, right? So we try to solve problems that are challenging on the UX side and not necessarily super challenging on the AI side, with the expectations that models get better and we'll just solve those problems better and better, which makes life easier for us and for our users, right? So it's been kind of interesting, the decision to be made, but how we expose which models are being used to the users and so on, right? There are users that are very well aware of the fact that there are different models and even aware of the differences between them. And then there are ones that just don't care. And so there's like a balance to strike there, and like, what choices do you make by default and what options do you want to leave to the user? And so not sure that answers the question, but happy to dig into any of that more if you want.
Yeah, I mean, I think maybe just super briefly, this isn't an episode on LLMs, but I think it is interesting. I assume a lot of the listeners will be aware of those 2 models, or I say 2 models, but given their various versions, but GPT and Claude. But it is interesting. I first experienced Claude through Type.ai. So that was kind of interesting, as well as my other half. She recently only discovered Claude. And of course, I've been well aware for quite a few months now as a result of Type. But her kind of experience of that model has now kind of changed her perception a bit of actually what's possible. So I guess, is that kind of how you've had to think about the choices as well? I'm just sort of, why Claude? Why not something else? Or why, would you consider taking GPT out in the future if there was something that made more sense? Or are you thinking just to keep adding models, or is there a reason it's 2 models? How did that kind of play into the decision making?
Right. So, I mean, I guess if you zoom out a little and you think about what are the sort of parameters informing, what to choose here, like, one is like obviously quality, right, of the model. The second is like cost, and the third is like performance, right? And so, but assuming those things, it's like you kind of just want to go with whatever is best at the moment, quote unquote best, that has like the best combination of these characteristics. And for the longest time, that was OpenAI. Then, right now there are basically 3 big players, right? It's OpenAI, it's Anthropic, and it's Google. And there might be more sort of players emerging. We'll see about that. But right now, those are the 3 realistic options if you want the highest possible quality. And for the longest time, OpenAI, I say longest, but it's only been like, 14 months or 16 or something, right? But OpenAI was like the de facto leader. And that lasted until, Claude 2 came out, Claude 2 Opus. And suddenly they had actually surpassed OpenAI in terms of quality. So at that point, it's just kind of like a no-brainer that you want that into the product and you want users to be able to leverage that increase in quality. And I think that's just how we're going to keep operating. We want to make sure the product works well with the models that provide good value to the users.
Yeah. And I think, yeah, just in case it's not clear to listeners, this sort of style of output from, say, GPT versus Claude is just quite different. And I think that's, especially in a document editor where you're trying to help people write better. I think certainly I love Claude for that purpose. I think it's light years away from GPT in terms of just what comes out at the end. But then I'm also, I mean, I've used Type.ai quite a lot, and but then I'm not always sure how much is the secret sauce that Type.ai has been putting on top. Because I'm aware, you ask for, say, tone reference or fact reference, and then how much is kind of Claude out the box. I mean, is there a way you can give a sort of simple answer to that?
Yeah, I mean, to be honest, there's not that much secret sauce in terms of how we interact with these models. I think the beauty of these models is that they are quite easy to interact with, and I mean, they're almost magical in that sense, right? But yeah, we definitely noticed too. So for our product specifically, right, there's like two sort of things to keep in mind, two tracks essentially in terms of how the model behaves. So one track, it's reasoning power, right, which is about telling it to do the right thing, right? So in terms of like getting it to, for example, modifying the right text, retaining the richness of the text, retaining the formatting, inserting it at the right place and so on, that is just pure reasoning power. Then there's the track of like, does it create actually good text in terms of like what the writer desires, right? And so now Claude has gotten to a place where it's clearly better at, I think, the latter, like producing text that writers desire. And it's also now better at the reasoning as well. But anyway, those are the two things to sort of keep in mind. And then in terms of like the quote unquote secret sauce is mostly about how do we get the models to do things behind the scenes so that it's just seamless for the user, no matter what operation they're kind of taking inside the application, which depends on the context, right? That can be whether you're in the chat or you're inlined in the document or you're generating a draft based on input and so on.
Yeah, and I think that's a sort of nice segue. I mean, a document editor for anyone is it's quite a personal choice. I mean, a lot of people it's forced upon them, I guess. You work somewhere and it's Google Workspace or it's MS 365. But at the same time, I think everyone kind of has their preferred, for me, generally speaking, it's Google. I much prefer writing in Google Docs than I do these days in MS 365. So I'm aware that kind of the experience piece to this, it has had to be a huge component to what the product is. As you say, you are building on top of these models. That does require quite a lot of effort in one regard, but actually a lot of the effort is in how you make this available to the user and what they're interacting with every day and on what device, etc. So that's kind of, I think, where we're going to go for a little while now, which is actually like how this was all really put together, like under the hood. And I'm just going to kind of dive in fast here because I know from day one, you've been quite, given that I also knew you when you were doing the flashcard startup as well, you've been quite kind of bullish on what could be termed as thick architectures. But maybe could we talk a bit about, in this context, what is thick versus thin at all, really? And how does this kind of relate to type? And, how does this relate to the sort of the concept of local first and so forth?
Yeah. So I think for me, the starting point is sort of like answering the question, what type of user experience are we trying to provide and build, right? And I think one way to do that is to look at sort of other applications that at least I admire and look up to as kind of role models, right? So that's applications like Linear, Figma, Superhuman, right? And these applications, they kind of have some common traits. They have like very robust syncing that kind of happens seamlessly. They are very fast. There's basically no loading spinners when you do anything in the application. There's no delay, and they are kind of collaborative in nature. Well, at least Linear and Figma is like Superhuman is less of a collaborative feature or collaborative app, but still, as we'll get into, it's almost the same challenge to solve collaboration as it is to solving real-time sync. But so yeah, for me, it's like I look at those applications and I go, that's the kind of experience I would like to deliver. At least that's what we're aiming for. I wouldn't say we're quite there, but that is kind of the holy grail. And yeah, so like two common things that these have, right? Again, it's like robust syncing and it's high responsiveness. And so if you think about what's the best way to solve that. It turns out that you kind of automatically go down the local first track. And yeah, let's see, how do we tease that apart?
How would you define, just for those that, again, aren't super familiar, how would you define local first?
Yeah, so there's kind of like the stricter definition. Well, first of all, it's actually like terminology that's kind of gotten more popular last couple of years, right? I don't know exactly when this thing was coined, but basically when it started, it was meant to mean all your data is always local. It shouldn't be dependent on a server. And essentially all actions you can take should be able to be taken with no connection. And even if the server goes down indefinitely, the app should still be able to function. And you should even be able to sync the data kind of locally between, say, two devices, even if there's no server. So that's like the really strict definition. There's kind of like a looser definition, which is essentially everything is still cached locally, but you still have some dependency on a centralized server. And that's like, I would say, the more sort of practical version of it, which a lot of these apps that I mentioned kind of fall under that definition.
Yeah. And in terms of, you kind of touched on it, referencing, some apps that you and Eli look up to, Linear, Figma, Superhuman. But again, why do it? I guess is then sort of like, what are the sort of the key things you believe you can deliver by taking a kind of local first approach?
Yeah. Again, assuming you want these two things, right? You want really high performance and you want robust sync. And then you maybe you want collaboration as well. So you start thinking about, how do I solve this, right? And well, the first thing that comes to mind is sort of like you need some form of optimistic updates. But if you do optimistic updates without being sort of fully local first, now you have the problem of like, follow-up updates that depends on your initial updates. How do you handle those, right? And you kind of play this out, and where you end up is sort of like, oh, this needs to be local first for everything to work, basically. And then you get the added benefit then when you go down that route of the app will work offline. And you will also solve a lot of the complicated issues that arise for collaboration, which is something we don't support right now, but we definitely aim to support it relatively soon. So one way to look at it is like, there's like kind of this suite of features and there's like a lot of overlap between them. And if you decide to go local first, you kind of just you're forced to solve all of them essentially. So I think that kind of is why do it, right? And again, this is all to kind of deliver the user experience that we believe is high quality, basically.
Yeah.
And to go one step further, or like, what does that mean in practice, right? So in a document editor like ours, for example, you should be able to create folders, create documents, edit the documents, search your documents. All that should be as fast as possible, instant if possible. And that's kind of the end result.
Yeah. So kind of covering off the key tenets of performance is clearly something that's been hugely important to you and what you believe for the user, which makes a ton of sense. I guess maybe some people listening could think that local first just automatically means that the offline experience is kind of solved. But I imagine there's actually quite a lot to still go in to make offline support actually an experience that is what someone would expect if they're aware that there is offline support whatsoever.
Right. Yeah, I guess, baked into the kind of what local first tends to mean, right, is that not just that the data is local, also that you should be able to sync it, right? So one way to look at it is that the offline part is actually simple. It just means like the app continues to operate when you don't have a connection, right? The hard part is like, okay, when you do have a connection later, how do you sync this data in a way where it's consistent across clients, right? Essentially, how do you achieve strong eventual consistency, which I'm guessing we'll dig into more later, right? But that's the crux of it. So that's kind of what makes offline first hard. It's the syncing.
Yeah, that makes a ton of sense. So before we maybe dive into the syncing mechanisms, I think it might be also just good to touch on the actual kind of state of the web that makes it even possible today. Because I imagine, as you mentioned, through a lot of your career, you were working with native applications. And kind of by default, I mean, I'm just putting it out there, I've never worked on native applications. I've always worked on web applications. So I assume for native, like local first is just that's just the default. And actually, we're now looking at how does web kind of emulate that? Is that a good way to think about it?
Right, because to your point with native applications, whether it's a mobile application or it's a desktop application, right? Per definition, you kind of download a binary and then that is installed. And then from then on, you have it, right? Which is obviously not the case traditionally with web applications. So the first question is, how do you even kind of cache the application itself, right? And the big unlock there is the Service Worker API that has been available for quite a while now. And so the Service Worker API essentially allows you to install a specific type of web worker, which is a separate thread essentially from the main JavaScript thread. And so it allows you to install that as a piece of code that will remain even as the browser tab or window closes. And the Service Worker allows you to intercept any request that your application does and gives you an opportunity to cache that request and to fetch something from the cache instead. And that is essentially the mechanism that allows you to fully cache your application. Not necessarily the user data, but the application itself, and allows that to be reloaded and used, even if you don't have a connection. And then there's like a bunch of other technologies that in conjunction with that allows you to, build the remaining pieces kind of like, so you also need some way of storing data locally. And most of the time that would be done through IndexedDB, which is a standardized web-based database. And then you have stuff like SharedWorkers and weblocks, which helps with some of the other pieces like coordinating between tabs. We can get into either of those in more detail as well. It's kind of cool. Like the last, I would say, 2 to 3 years, a lot of these things have started, maybe going back even further, right? But kind of maturing to the stage where you can now do this on the web.
And what's the difference between a service worker and shared workers?
The intent of a service worker is to do what I said earlier, right? It's to cache the app itself and assets that the app might fetch through HTTP requests. Now, it can be abused to do other things as well, which we have done in the past, which is probably not a good idea. But that is essentially what it's designed for, what I just mentioned, right? And so it has like a very sort of specific life cycle that is designed with that in mind, that decides how do you update the service worker, when does it start, when does it stop, and so on, right? Whereas a shared worker, they seem very similar on a high level. So it can be hard to tease out the differences. But a shared worker is similar in the sense that it's also shared among tabs. So there's only one instance of it running, but it has a different life cycle. So it starts very rapidly when you open up your first tab. It closes down rapidly when you've closed all of the tabs. It remains alive at all times as long as there's a tab open, whereas the service worker can kind of shut down at any moment. There's other differences too, but I would say those are the main one. And like, so the shared worker is what you would go to for sort of coordinating between tabs, right? So for example, if you have a synchronization process, which we have in our case, but you only want one instance of that process running, no matter how many tabs you've opened, that would kind of go into shared worker. Whereas the service worker, it just caches kind of like the assets of the application. We tried to use the service worker for some of the stuff that we now do in the shared worker, and we saw some issues there. The problem with the shared worker is that it's still not available across all browsers, actually. It's relatively new in its current state, and Android still doesn't have support for it. So we actually don't support multiple tabs on Android. That's the reason why we try to kind of abuse the service worker a bit there. But yeah, those are basically the differences.
Okay, yeah. I think it is different, but my point of reference is Chrome extensions, which also use service workers, different type, I believe. But I think some of the challenges are kind of similar. And even just the fact that you can't actually have a Chrome extension on an Android phone is fairly frustrating as well. So some similarities there. I'm aware that, you've gone through a couple of major iterations at this point. So kind of, I think the way you termed it just in our pre-chat was sort of Sync v1 and Sync v2. And I think it's always really interesting to hear kind of how actually a product has been evolved behind the scenes, because no one actually is still running what they were running 2 or 3 years ago at this stage of a product. So yeah, how would you what was the first version of syncing and how did that kind of operate? And then how and why have you moved to a sort of second full version of that?
Yeah. So maybe I'll do it the other way around, actually. I'll tell you how it currently works, and then we can talk about why it needed to turn into that. So we have like an event-driven architecture, essentially. So any action that you take in the application, say you create a folder, for example, results in an event. And that event will then propagate through the system. And so on the client side, it'll pass through a couple of stages, right? So it'll update the application state in memory, which immediately is reflected in the UI, right? And then it will update the state on disk on the client, and then it will get uploaded to the server. And on the server, it'll first get applied to the state that's on the server, and then it'll be added to essentially an event queue so that it can be distributed to any other client, whether they're online or not, right? So if they're online, they'll receive it immediately. If they're offline, they can pull it once they come online. If you zoom into the client piece a little bit, there's a couple of different processes. There's like one process that's responsible for uploading these events. There's another process that's responsible for downloading new ones from the server. And then there's one process that's like responsible for coordinating and applying all these events to disk. And the reason the system is designed this way is so that it can be sort of completely non-blocking. So you can be synchronizing, meaning uploading or downloading events and taking actions in the UI at the same time, and there will be no interference. And that's something that wasn't possible in the first version. The second big piece is that we've turned all our data structures into CRDTs, essentially. And yeah, we can get into CRDTs more, right? But the sort of high-level features that CRDTs allows us to rely on is that our events can arrive in any order, which makes the system more flexible because there's like less concern about race conditions and things like that. It allows us to basically focus on the fact that an event needs to reach all of the nodes in the system. Nodes meaning multiple tabs, multiple clients, and the server. Right? As long as we know that any event reaches all nodes, we know that the state will be consistent across those nodes. So that's how it works today. And in the previous system, our data structures were not CRDTs, but we still had this kind of event-driven system. And so we were reliant on the events coming in at the same order, essentially. And how can you guarantee that, right? Well, so one way to guarantee that is that let's say you've been offline for a while, so you've created a bunch of events, and now you go online and you try to upload these events, but there are new events on the server that have arrived while you were offline. So now it's like you can't just send those up because now they'll be out of order. So one way to solve that is to do a rebase. Essentially what you do in Git, right? So you rewind all of the events locally, you download the server events, then you put your new ones on top, and you do any conflict resolution needed during that phase. So for example, let's say you moved a folder into a folder that's deleted, right? After the rebase. Now you can just like decide what you want to do in that case. The folder no longer exists. Well, maybe you decide, okay, we just don't move it then. We ignore it. So you can do that during the rebase phase, right? Now you know, okay, now it's okay to upload those events to the server because the server is in the same state that I was in when I applied those events. So now with the new system, we don't need that whole rebase mechanism, which simplifies things. It also simplifies the multi-tab, the problems involved there. And there were other problems with our old architecture. Like I said earlier, we were kind of like abusing the service worker for some stuff that we're no longer doing. So it's just overall a lot more robust, and it's also more prepared for multiplayer, which you want to add in at some point.
Yeah. So I guess just to sort of rewind briefly, so the system today is CRDT based. That's conflict-free replicated data types, just for anyone not super familiar with that acronym. And I guess seem like an obvious question because we all start one way and then realize it wasn't the right way. But why did you actually not start out with that approach?
The first thing I'd say is that, I had not built a system like this before. I think it's actually, today it's like much easier to find material on how you should structure the overall system. So I should say, for the audience, I started on this infrastructure on the previous project, right? That then kind of transitioned over into Type. But when I started that, there was just less information out there. Also, frameworks in general around things like CRDTs, for example, were much less mature. Also, the system, the sort of Sync v1 system, it did work, It's just that it didn't feel quite future-proof, right? So, so the answer to that question is, I guess, one, just experience, experience gained, and then new software becoming available through libraries, new learnings, all that stuff.
Yeah, I think that's really important. And it's something that I've known you for quite a while. So, we have various chats, and I've always been aware that you don't settle for second best when it comes to engineering. And that's what I love, is that, you can take an approach, but it's totally okay to accept that there's now something better you could be doing. And I think a lot of people would actually just say, well, it works. And yeah, it might not scale as much as we want it to into the next 3 years. But hey, I think something that probably you and I share is that sort of level of engineering quality where if we know that something can be done better, it's very difficult to ignore that and wanting to go back and actually do it kind of the way that you now know makes sense.
Everything can always be done better, right? So it's a matter of where you kind of draw the line. I think, I can look at a lot of software that's like done, better than what we're doing. And so clearly they have drawn the line further away. We all have our own frame of references in terms of, okay, what constitutes the right sort of quality bar. And I think at the end of the day, it comes down to, for me, it comes down to the user experience. Is the system robust enough to provide the user experience that you want to build? And if it isn't, then, ultimately you're going to have to sacrifice on the user experience side, right? And then you're not building what you want to build. I think that's at least how I try to look at it. And so you don't want to have something that is complex and super elegant for its own sake. It should be to kind of serve a purpose to the user at the end of the day. I don't follow that rule exactly all the time, but that I try to use that as a kind of guiding compass.
And just diving back to CRDTs briefly, I was talking to another startup CTO, and real time and offline is important to them as well. And he mentioned YJS. And I think I briefly mentioned that to you, and you said, I think you're partially using YJS. So I think just to take a step back, what is YJS and how are you guys utilizing it?
Yeah, so YJS is essentially a CRDT library. So it provides primitives that are CRDT data structures. So yeah, if we back up a little bit and, we talk about what's actually a CRDT, right? So they're both kind of simple and complicated at the same time. So to try to do the simple take, right? It's essentially data structures that allows you to, well, so first of all, there are different CRDT types. The type I'm referring to now is called, I think, Delta CRDT. So when it comes to Delta CRDTs, what they are is a data structure that allows you to create deltas that will take that data structure from one state to another. So that if you now have duplicate 2 copies of a state, right, you can update them both through some kind of patch. And which in itself is, nothing crazy. You can obviously build anything. You can build like a map has those type of characteristics, for example. But the special thing with the CRDT is that the delta has these 3 kind of mathematical properties, right? So they're associative, commutative, difficult word to pronounce, and idempotent. So these are like, for people that remember math from whatever college, it's like commutative means that they can the patches can come in any order, essentially, with the same result. Associativeness means that the patches themselves can be merged in any order, and the result of that can now be merged with the state, and you'll still see the same result. And idempotent simply means that you can apply the same patch multiple times with the same result. And so that's basically it, right? If you build a data structure that qualifies in the sense that it has these three properties, you essentially have a CRDT. And so for simple things like, let's say you have I think one of the simplest CRDTs is like a grow only set. And so a set that only grows and you never delete from it. That's like, you can kind of reason yourself into building that very simply, and that's a CRDT. But let's say you now have a text file, and you want to be able to make arbitrary modifications to that text file, and you want that to be in the form of a CRDT so that updates are consistent across nodes. That becomes very, very complicated. And the engineering behind building that is probably something you don't want to do yourself. And so that's an example of something that YGS provides out of the box. It also provides primitives like lists and maps and sets that are sort of CRDT compliant, for lack of a better word. So that's definitely a tool one can use when creating this kind of a system. So we use YGS for some of our things, and then we have kind of homegrown data structures for some other stuff.
Yeah, okay, super interesting. Can you give like an example? I'm super curious. What's an example of a homegrown data structure that doesn't fit YGS in your case?
Yeah, it's not that it doesn't fit necessarily, but YGS is very powerful, but it's also not super ergonomic to use. And it does stuff like compression and so on, right? So your patches come out as like just a byte array, and there's a lot of kind of black magic involved, right? So if you're doing something that could be designed fairly simply as a CRDT, so for example, in our case, we have our chat logs needs to be synchronized across clients, right? That can be actually relatively simply done without using something like YGS. You basically make sure that all of the events have timestamps, logical timestamps. You design it so that's like you have absolute ordering across clients and some stuff like that. And you have essentially a CRDT. And then, so in that case, for example, it's just overkill to use YGS essentially, because you'll just end up with a lot more opaqueness, for lack of a better word.
Yeah. Without being ultra familiar with YGS, I can understand what's going on there. As soon as you're working with byte arrays, life gets more challenging. That's just key thing either way. I work with them when it comes to WebAuthn effectively. And luckily there are libraries and episode that was on in the past. It helps deal with them, but it still isn't simples, shall we say. So I can understand that. We're cruising sort of towards the end of the episode, but just you've talked through kind of one of the main challenges that you've been solving over the last few months. Where do you see what sort of are the next maybe challenges, let's just say from a pure engineering standpoint for now, like challenges and or upgrades that you're kind of looking at with the product?
Yeah, we just finished this kind of re-architecture of the sync system. And I think that took about 2 months, right? So that's like 2 months with no new features, which is never great when you're trying to find product market fit. So we're going back to just kind of feature building mode now. And so it's hard to say exactly what the challenges there are always numerous, right? But we have a couple of features in the pipeline that we are excited about. I generally just don't like to talk about things before they're built, simply because I want to see that we can actually deliver on what we're trying to build. But it'll be a combination of sort of challenging UX stuff, and as usual, the challenge of being able to talk to these LLMs in a way that gives us good results.
Yeah, nice, exciting. Well, anytime I see feature update emails come in, I'm usually pretty excited, and I head in and start playing around with the new things. So that's exciting. Where, given that the audience, if they've heard a lot about the product, especially some very detailed parts of the product, where's the best place for them to kind of get a feel for using Type.ai? I guess it's Type.ai.
Type.ai, correct. Yep, just go to type.ai and check it out.
Okay, well, yeah, Stefan, fantastic to have you on today. It's always a special one for me when I get to bring on someone I know very well. So I really appreciate you taking the time in your evening, New York evening and morning over here in Singapore. So really appreciate the time. You're obviously a very busy engineer, so giving up your weekend to talk about this, and I'm sure all the listeners really appreciate it. So thanks for coming on.
Yeah, thank you. It's been fun to be here. And appreciate having me on.